Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now I am going to solve this problem from engineering statics. In this problem we are given that the weight of the printer is 80 pounds with the center of gravity at point G, and it is said that determine the moment MO of this weight about point O on the horizontal tabletop and find the magnitude of MO. Right, so we have to determine the moment due to the weight of this printer at this point O. Right, so if I draw the weight of this printer, which will be acting vertically downward in the negative z direction. This is our positive z axis, right? So the weight will be acting vertically downward in the negative z axis, and its magnitude is, we can write that its magnitude is 80 pounds, right? So we have to determine that moment about point O. So moment about point O, if we use the cross product method, right? So then we have to write R cross F, or we can say that R cross the weight of the printer, right? So we have to define the moment arm, right? So let me draw that moment arm. So that moment arm, we can say that the moment arm can be from point O to this point G, or the moment arm could be from point O to point E, right? So the definition of the moment arm is that it is the vector from the point of rotation to any point on the line of action of the force for which we want to determine the moment, right? So now we can define our moment arm this vector, or we can say that this could be our moment arm, right? So now I will, for this problem, let me choose this as the moment arm for this 80 pound weight. So this is now our moment arm, and this moment arm is from O to E, right? So now if I draw the components of this moment arm, right? So this moment arm will have one component in this direction, right? And it will have another moment arm in the positive y direction, like this, right? So this is Rx and this is Ry, right? So if we write the moment arm as a Cartesian vector, so then it will be equal to Rx plus Ry, and we can say that Rx is acting in the positive x direction and its magnitude is 24 inches, right? So I can write that this is 24 positive I, right? It is acting in the positive y direction, and Ry is acting in the positive y direction, right? And its magnitude is 48, right? So I will write that this is 48 J. So this is our moment arm, right? And the weight, we can write that weight as a Cartesian vector as well. So that weight has a magnitude of 80 pounds and it is acting in the negative k direction, right? So this is the Cartesian vector representation of that weight. So now we can write that this moment about point O due to that weight is equal to 24I plus 48J. This is our moment arm cross that weight, which is minus 80K, right? So now we can use that determinant method, right? So this is I, J and K. This is 24, 48 and 0, and this is minus 80, 0 and 0. So now this will be 48 into minus 80 into I. This is minus J, right? With J we need to write minus, right? This is the determinant method, right? So minus 24 into minus 80 into J, and then K term, right? So this is plus, and this is 24 into 0 and 0 into 0, so this is 0, right? So 48 into 80 is 3840, right? So this is minus 3840I, and this is minus into minus plus, and 24 into 80. This is 1920, right? So 1920J, right? So this is the moment about point O. This is the Cartesian vector representation of that moment about point O. And further in this problem we are asked to determine the magnitude of MO, right? So the magnitude of MO will be equal to, we can use that Pythagoras theorem, right? So we can say that this is mx square plus my square, and this is that mx, and this is the magnitude of my, right? So we can say mx is 3840 square plus 1920 square. So this is 4293.25. So 4293.25, and its units will be pound inches, right? Since this moment arm is in inches and this is in pounds, right? So the units of this moment about point O is pound inches, right? So this is the solution of this particular problem.